Hi everyone, how are you? Today we'll finish our class. We're gonna try about conductors, voltage and electric field. We're gonna do summary first, then we will solve some problem. Then we're gonna do some summary, then we're gonna solve some problem. Okay, let us start and review. I have here a table to show you what I mean, what we did. Now, this is my sphere. Remember these conductors. Conductors mean the charge comes in the top always. Conductors, there is no charge inside. Okay, that's what we did. Inside the sphere, always at any point, electric field equals 0. Inside the sphere, voltage KQ over R. From the origin to from the center of the sphere to the surface of the sphere. Now, second case, which is when we have a need to find on the sphere here, on the surface. E equal KQ over R squared. There is no electric field inside. The voltage stays the same from here to there. And we explain that, and we explain why the sphere, why the electric field. Yesterday, if you back to the video, you will see why the electric field inside 0. I explained it yesterday. Outside the sphere, the whole sphere becomes a point charge. Look here, we can do it like this. You see all this, when we go outside the sphere, all this guy, all the sphere becomes what point charge, Q, at a distance D. That's it. We're gonna deal with the sphere, when we are out the sphere, we're gonna deal with the sphere as a point charge at a distance. If you're gonna find the electric field here, we're gonna assume there's back also to my electric field for point charge, we have to assume there is a charge. There is a charge equal to +1 at the point where we want to find the electric field, and we have to find the direction always. If this guy is positive, then the electric field will point this way. If this guy is negative, the electric field will go this way. Okay, that's what we did. Also, what we did last time, we got the graph, the relation between the electric field, how the electric field changing from the center of the circle, here, all the way to here, 0, 0, 0, 0 there. At the surface, the electric field has what? A value. At this, which is this value. This is what we need. Then after that, the electric field drops very fast. Okay, let me just this to be D squared. This guy to be D squared. D squared. Okay. Very fast. But for the voltage, this R, it's right. It was right. Okay, it's R squared at the surface. Then we talk about the surface. Okay. Now, for the voltage in Newton meter per column, the unit, and the unit for the electric field in Newton per column. From the center of the sphere to the radius, we have the same value, it never change, which is KQ over R. Then after that, go, look here the difference. This goes very fast, you know what I mean? That guy was slower, because this we have here 1 over R squared, and here we have 1 over R. Then that goes slower because 1 over R, and this guy goes faster because 1 over R squared. Okay, let us take some example. Let us start with this example. Okay, there is sphere, the charge in the sphere, Q equal -3 microcoulomb, and the radius of the sphere is 8 centimeter. Then what I have, Q on the side, -3 microcoulomb, R equal 8 centimeter. That's given. That's given. What he wants, this guy, the one, V. A here. Fine. EA, EB, EC, ED. AE, okay? Let us go. Note that A and B in the sphere, inside. Quickly, I will say EA, quickly without EA equal EEB equal 0. Good. Now, EC, this one, 2. EC, K, Q over R square. Why R square? Because C on the surface. K, I told you K is 9 times 10 to the 9. And the Q, now Q is negative, but for electric field, you don't put negative, you put only 3 times 10 to the negative 6. 3 times 10 to the negative 6. Okay. What's R? 8 centimeter. I have to go from centimeter to meter. Centimeter to meter, always 8 centimeter equal 8 times 10 to the negative 2 meter. You multiply by negative 2. Remember, when we have centimeter, you have to do this. Then 8 times 10 to the negative 2. Look, I'm going to show you something. You can use calculator, I don't mind, but I'm going to show you some skills if you want, guys, and you can use calculator. Okay. Multiply 9 times 3, 27. Rules of exponents saying if you have the same base, 10 and 10, you add the exponent. 9 plus negative 6 is 3. And square this. 8 squared is 64 times 10. Also, rules of exponents saying you multiply the exponent, which is negative 4. Okay? Equal 27 over 64. This guy over this guy. We have the same base, which is 10 for the top and the bottom. In here, we look here, negative 4, this 3, and this guy is what? In the bottom, negative 4. Good? 3 stays 3, but when you bring negative 4 from the bottom to the top, from the denominator to the numerator, that gives you plus 4. My final answer, 27 over 64 times 10 to the power 7 Newton per column. Okay. You have to have the unit. No unit, you lose point. Now, E and D, that's what you want. E and D, how much the distance? Look here, I gave you distance D 12 centimeter. To find the big D, you have to find the big D, you have to add the radius to that, this. Then E at D equal K Q over D square. Now D equal, here I'm going to do it for you, D equal 8 plus 12. 8 is the radius of the circle, and 12 is the distance. Equal 9 times 10 to the 9, the same chart, which this 9 times 10 to the 9 is a constant, never change. 3 times 10 to the negative 6 over the distance now 20 centimeter. 20 times 10 to the negative 2 square. Why negative 2? Because we have centimeter. Okay. And this equal, as we did, let me move this guy down a little bit. I need this later on. This is another example. If we have time today, we will finish it. Okay, let us put this guy here and back to our problem, because we need more space. We need more space. Now, this is finish it, guy. Let's just simplify your answer. E as D equal 9 times 3, 27, 10 to the 3, 9, and negative 6 over 400 times 10 to the negative 4, which is 27 over 400 times 10. What we did before, 3 plus 4, 7 Newton per pound. Left one thing I have to finish it, which is the direction. Remember, E is a vector quantity. E is a vector quantity. What's the direction of the electric field? Look here, this is, I'm gonna put here the 2 point I found C. Now the whole circle is the whole sphere becomes a point charge at A for our calculation. Then I have point A, the charge, which is Q, which is negative. Q here is what? Negative charge. Now point 2 point has electric field C and D. C and D. C. Then to find the direction of the electric field, you have to assume there is a positive charge plus 1, and this is negative, and this positive. Then the electric field E at C comes like this. The other point, which is D, which is here, also we have to assume there is what? A charge plus 1 at that point. That means this is negative, then this guy will come again what? The same. Then my electric field to the left, negative x-axis, which is E at D. Now let us find the voltage. He wants the voltage at A, B, C, D, right? The same thing, V, A, B, C. Now, look here, lucky you, voltage, VA, VB, VC. The voltage from the center of the service, from the center of the service, till that the service itself, it's the same exact value. Then again, that value of the voltage from the center to the surface of the sphere is the same, which is equal to KQ over R. Now, Q, you have to add to keep it the same. If it's negative, negative. If it's positive, positive. Not like the electric field. R is how much? 8 times 10 to the negative 2. We don't have to square. In electric field, we square. Now, I lift the charge in. The charge is how much the charge, guys? How much we have charge? 3. But now the charge is 3. Negative 3 times. You see what I did? Negative 3. Negative 1, negative 6. Remember, microcolumn is 10 to the negative 6. Microcolumn is 10 to the negative 6. Microcolumn is 10 to the negative 6. Now, just calculation equal 9 times negative 3, negative 27. 9 plus negative 6 is 3. Ten and 3 over 8 times 10 to the negative 2. Negative 27. there is no direction for the voltage. 10 to the 5. Why 10 to the 5? Because when you move the negative 2 to the top, you add plus 2 volt. At D, now the last one, V at D. V at D. V at D. We have how many minutes we have? V at D equal K Q over D. And remember D is 8 plus 12, which is 20. 9 times 10 to the 9 times negative 3. Why always, you see again, negative 6 over 20 times 10 to the negative 2. Calculate it and do it in different color. 9 times negative 3, negative 27 over 20 times 10. Now look here, 9 and negative 6, leave it the same. 9, negative 6. 9 minus 6, you can do one step now. The negative 2 comes up, becomes what? Plus 2. You see what I did? 9 minus 6, because they are the numerator. And the one in the denominator, you bring it up to positive. Equal negative 27 over 20. You can simplify this more, but for now, that's good enough. 5 and volt. Don't forget the unit. Don't forget the unit. Have a nice day, guys. Tomorrow I'm going to solve one more problem or two more problem, and have a nice day.